Hey there, everybody. I'm back. We are working on our Scratch project. We are, I believe, 2 videos away. This particular video, I've got some huge goals. This is part 7 of our asteroids. We've got our asteroids, we've got our ship, we can shoot asteroids, they get smaller, we got score. I really need to fix the movement. And so here are my goals for this video. Is to solve the movement problem. Now, even is this problem? The big problem, as I see it, is that if we're drifting, okay, so let's say we're pointing at the upper left-hand corner, and we start moving up there, and then we start to turn, we'll start actually just going in that direction. We just keep moving in the new direction. It's sort of like it's hard to explain what I'm trying to do, but it's the idea here. If we're gonna if we're gonna be like moving in one direction, we should be able to like let go of the thrust and just start spinning. We'll still keep going in the direction we were originally heading. We'll just be spinning while we're going because we're out in space. Okay, now let's forget the idea that I'm going to be applying friction in space. We'll just ignore as if that didn't happen, there wasn't any friction, but we're going to do that. It's just part of the game mechanic, not total, actual, realistic physics. We're calling it fun physics, as other people I've heard call it. So the idea here is that if we are turning and applying thrust, we'll basically begin to change our direction in the new. We'll change our velocity into a new direction, which is a vector. So it all has to do with vectors. Okay, so we need a little momentum. In other words, if we're already going at full speed in one direction and we turn and start applying some thrust, we're not going to just automatically go at the new direction full speed. We're going to keep having some of that initial momentum, also known as impulse. That's the word I was trying to think of. But here's the solution we're going to do. So when we apply thrust, we're going to apply a vector to our current vectors. We're going to do some vector addition. And rather than just completely start going in that new direction at the exact same speed we were, we'll be continuing our momentum. Two ways to think about it is if there's a plane flying with a wind at like a crosswind or a tailwind or a headwind, it's going to change the direction and it's going to change the magnitude. So think about that vector. It has both a direction where are we pointing and magnitude, how fast are we going in that direction. You can also think of it like rowing a boat in a river with a current. So let's just take a look at some of those pictures, some examples. So we've got a plane. Let's say the heading of the plane is pointing in the direction of this solid arrow, but there's a wind that's coming at it as a crossway going this direction. As the wind hits the plane, it's actually going to have a result it's going to change its direction because it's adding some wind. It's actually going to go a little faster. So even though the plane is going at a certain force in a certain direction, that wind is going to set it off its course. So in a way, it would be as if we're midship and we took our plane and we turned it in the direction of the arrow and started applying some thrust. It's going to sort of add to that. The other analogy I use is this idea of a boat. Let's say you're rowing your boat directly across the river, but the river is flowing, in a direction. The end result is your boat is not going to be at the other side of the shore. It's going to be at the other side of the shore, but down lower, because we've applied another vector, which is the case of the river. Well, in our case, we're in space, but if we turn our ship, let's say we're initially heading in this direction towards the right-hand side, but we turn our ship and we point in this direction. Now, if we don't apply any thrust, we will still have the momentum heading that direction. But the moment we apply the thrust, it's going to now not head directly this way. If we're pointing towards that arrow, we're going to start heading towards that arrow and moving in that direction. If we were to point directly down and apply a certain amount of force, we would go diagonal. So that's kind of what we're trying to do here. Now, I've got a lot of credits I'd like to go over, but just so you know, we're going to use some concepts. We're going to use the concept of vectors. So vector, again, has both a direction and magnitude. Okay, the direction is going to be affected by our left and right arrows. The magnitude is directed by our acceleration or deceleration. We're going to have reverse thrusters now. We're going to make it a little more interesting. We're going to use this concept from trigonometry called the unit circle. And what I've kind of learned a little bit and have talked about in previous videos is normalized vectors. Believe me, I spent a good chunk of today working on it. We've got some information from Khan Academy, and actually I already have it open over here. This video has been very helpful for me to sort of visualize and make sure I know what we're doing. The idea of the unit circle would be a direction. If we were to go in a certain direction, but we are only going to go 1 unit in that direction. So if it's straight up and we go in 1 unit, we would change y by 1, and we would change x by nothing. We'd just go straight up, but we would end up here. If we're going to go directly to the right, we would just go 1 to the right. That's the unit circle. Sal does a much better job explaining that. He also then explains the math is to get our x direction. So let's say we're pointing at 50 degrees, and we wanted to know how far we would head in the x position. We would multiply our angle by cosine. And if we want to figure out the y, we multiply our angle by sine. Okay, so let me see if I can explain this to you. Here we have the unit circle. You can see we cannot go any further than an x of 1 to the right. We can't go any more left than an x of -1. We can't go any higher than a y of 1. We can't go any lower than a y of -1. It's all based on 1. Okay, if we take a number 1 and we multiply it by any other number, let's say 5, let's say we're going to give our thrust power a value of 5. All we have to do is take that number 5, multiply it by the directional vector of x and the directional vector of y. So let's say we want to go to the right. The heading to the right is 0 degrees. So cosine of that angle, 0 degrees, remember there's no angle because we're going straight to the right. Cosine of that angle should be the value of 1. So let's just verify that with my handy dandy calculator. So we go to trigonometry and we are doing the cosine. See, I had to remember that. Notice the value was at 0. Cosine of 0 is 1. Let's say we are going to go 180 degrees. So I type out 180 degrees. Now, if I were to take that, we add 180 degrees, we're pointing all the way to the left, half of 360 degrees. So we take 180 and we get the cosine of it, we get the value of -1. So we're heading -1. So if our angle is 0 and it's 1, and we apply thrust in that direction of a value of 4, we multiply 4 by 1, that becomes 4 units to the right. And if our angle is 0 and we take the sine of 0, let's see what it does to y. So I go back and I hit 0 in and I do the sine. Sine of 0 is 0. So we don't go up at all. Okay, if we're going to go 90 degrees, that means we're heading directly up by 90 degrees. And we get the sine, we're going to get the value of 1. And of course, if it's 180 degrees, sine is going to be 0 because we're not, we're going to the left, we're not going down. If we're going to go all the way down, that would be 270 degrees, 7, 0. That's what I want. Then it becomes -1. We're going down by a value of -1. So the directional vector just gets us our heading with a value of -1 to 1 in any x or y location, and then we just multiply that because 1 times any number is that other number. This is what got me going. Randy Gall's game programming blog. Now this is the algorithm that I used. However, it turns out I had to spend a lot of time because there is a particular problem with Scratch, and it has to do with the way it deals with angles versus trigonometry. And I believe that gets me to my first phrase that pays for all of you students out there that are students of mine watching, and you want to get credit for having watched this video. The first phrase is that the new movement is by applying vectors. When we apply thrust, we need to apply a vector in the direction we are heading. That is our first phrase that pays. I'm going to go right to the second one. We're going to do 2 in a row. Number 2, the problem with Scratch, which is what I just brought up, is the direction of 0 is up. And that is going to affect all of our angles because according to trigonometry, a direction of 0 is to the right along the x-axis. And unfortunately, 0 in Scratch is heading up, and that's going to cause a problem. So the problem with Scratch is we have to fix it. So I went to this one particular one on trigonometry. That was the other thing I had to double check to learn about angles. And they gave me this cool little formula that helped me solve some of the problems that I had. Now you're probably wondering how we're going to get to all this stuff. It sounds pretty complex, and it is. And for that reason, I am going to simplify things. So in our Scratch game, which I believe I have open over here, the first thing you'll notice is I have done a lot of refactoring. And refactoring is when we take our existing code and change it. Now, a lot of this stuff has been done before I did this video, so I need to explain a few things. Okay, the first thing you're going to want to do, if you've been following along and you have your Asteroids game, it's time to refactor. It's time to rethink your code and do some serious changes. So the first thing is we want to keep the ships, the can shoot, and the score. We're going to keep that as is. And all these other variables are similar to ones we've had, but were ones that we are going to use. So let me go over each of these variables, and then this is going to get us to a few more phrases that pay. So you're going to need to go in here and you're going to need to make some variables. You click make a variable. Whenever you make a variable, remember you have a for all sprites and for this sprite only. If you are not sure in this case, do it for this sprite only. Most of these variables from acceleration forward to friction are all ones that we are going to use as variables. Okay, that are for this sprite only. Okay, not for the whole game. The only one I changed is pi, because I think pi is something we may use in our other scripts, on other sprites. So we'll do that. So we set some variables here, and let me go ahead and walk you through what each one is doing, and then we'll put it all together. The first thing you'll notice is I've got 1, 2, 3, 4 different variables, 5 if you count this one down here, that are in all caps. Now what the heck is going on with that? Well, these variables are constants. They are not intended to be changed. Now, you can change them in Scratch, but we don't want to, which is why we make them all caps. Now, this is a convention that most programmers are doing and should do, and that is make it an all uppercase to indicate that it's a constant. It's a variable that's not intended to change. Okay, which brings me to another phrase that pays. We're on number 3, right? Number 3 is constants are variables that do not change. We make them all caps to make it more obvious that they are constants. Okay, so what are they? Acceleration forward, we gave it a value of 2. And this is going to be when we apply thrust, we're going to be applying that number to our thrust. But we're going to, as long as we're holding it down, we're going to keep increasing by our acceleration. And we have a backwards acceleration, so we can do the down arrow and move backwards. We're going to set that to -2. We're going to have a rotation. The speed at which we rotate to the left or to the right, we're going to set that to 2. And then we're going to set the value of pi. And the way I got this is I literally just got onto my browser. I don't know if you know you can do this. And I typed pi in space. You hit pi and hit enter. You get the value of pi. So I just actually copied it right here. So that's also a constant, so it's capital P, capital I. We created a couple other variables, velocity of x, velocity of y. We initialize those to 0 because at the beginning we're not going to move. When we do movement, we're going to move in the x and the y direction, and that could be positive or negative. We also have a maximum velocity, and I set it to 8. If you want to slow its maximum speed down, you lower that number. You want to make the maximum speed faster, you increase it. We're actually going to add a little friction, and we're going to multiply our current velocity by that amount, so it always starts getting smaller and smaller until it's at 0 or close enough to 0 that you won't see any movement. Okay, so that's what the friction is there to do. And we have our first function that you're going to need for this program, which is to convert Scratch to trig degree. We have a direction, and when we point in the direction of 90, which I think is what we had before, you could double check, We had it before. When I hit start, I want to be facing the right. 90 degrees, if you look here, is pointing to the right. Of course, to get it to point to the right, we're going to set it to 90 degrees. But what we want to do, it's called trig degree result. So I will do that for you. But to save time, let's just take a look at what we're doing here. So what we want to do is we want to take our scratch degree and turn it into a variable called trig degree result. So that in the end, the value of 90, which is what we set up here, actually becomes 0. So that when we start the game, we are pointing to the right and we are heading in that direction. And that's going to be key. So we need to be able to point and head in the direction we're pointing. So before I do that, you'll notice the costume of the ship is already pointing right. If I click on costumes, you can see that it's pointing right. So you want to make sure that you get your ship pointing in the right direction. Point it to the right, or else change your variable when you get there. So we're going to set a variable. So once you create your variable, you'll see down here you have a set and you have a change. So we're going to set the degree, trig degree result. So we're going to take the scratch degree, which is an input. So basically when we drop direction in here, that direction was originally set to 90. 90 comes into here, and then scratch degree represents that value. And we're just going to think about 90 for a bit. Now, before I go into all this math that we're doing here, let me also explain a couple other things. When we point in a direction, I want to point this out, ha ha ha. So in Scratch, we have 0 through 180, but the moment we go to the left, we have negative values. Now, I don't like that. It kind of messes things up, but I like the idea of always having a positive value of a degree that's a heading between 0 and 360, or in our case, 359 to 0, 0 to 359, a total of 360 degrees. Okay, so like I said, we're going to point in the direction of 90, points us to the right. That has to ultimately become 0. And I want it to be a positive value. So to get it to 0, what I'm going to do is I'm going to add 270 to the current degree. By adding to the degree, and let's take a look at direction one more time, when we set it here, remember, 0 is, okay, so if we go to the right, we're going up a number. If we're going to the left, we're going down. Okay, I want to end up with a positive number, so it's better to add. If I add 270 to 90, oh gosh, let me just do a Control Z. If I add 270 to 90, then we are going to get 360 degrees. So what I do is I do this math function called mod, gives us what's called the modulus. And the modulus just produces a remainder. So we're saying take this number, divide it by 360, and if anything's left over, that is the remainder. So if 270 plus 90 is 360, we divide 360 by 360, that gives us a remainder of 0. In other words, our 90 degrees now becomes 0. And so as long as we're doing the mod 360, it can never be more than 360. And since we're adding 270, the lowest possible number we could get when we set that direction, because that's what we have to think about, would be negative 179. So if we have negative 179, we add 270, we're never going to be at a negative number. So one of the things that might be worth doing is to open up that trig degree result. So I'm going to open that, and then we're also going to make that direction live. And click on, I'm going to check direction. I'm going to full screen this thing. I'm going to hit start. And you'll notice the trig degree is 0, ship direction is now 90. So we've just converted that. Okay, from that now we can do some of our trigonometry. And before we move on, I just want to talk about a fourth phrase that pays, which is code refactoring. Code refactoring is the key phrase here. It is a concept that programmers do all the time. You build a program, you get something working, and then you decide you want to make something better, which is exactly what this video is all about. We're refactoring our code to make the asteroids movement more like the traditional arcade game. Big thing about code refactoring is I want to talk about what we did to our keyboard control. In order to get this working, what you're going to want to do is you're going to want to take that start, when I receive start that has the keyboard control, and I want you to just toss out everything in the forever, because we're gonna do our movement totally differently now. So differently that it's best to just grab everything in there and just delete it all. Okay, so go ahead and do that. It's the first step in code refactoring. Actually, our first step was to go into our variables and set them. Let's take a look at our variables just as a reminder. Actually, I'll show you when you see a new variable. Let's just see what ones we haven't set here. Direction of x. Okay, so we created a couple other variables that you should know. One is this dirvect x. That stands for directional vector x. Dirvect y is for directional vector y. And what we want to do is we want to basically, this directional vector x, directional vector y is going to be between -1 and +1 in the x, the y, and the z. Okay, so I said I was going to show you how to create a block. So what I'm going to do is I'm going to make a block, and it's called, it's over here. It's called set radian orientation. So we're going to use radians to set our orientation. So I'm going to make a block, and we're going to type out set radian orientation. And this one does receive an input, I believe. Let me double check. No, it does not. So we're just going to delete that. And we're going to click OK. And right away, we have a define radian orientation. Okay, so the first thing we're going to need, we need a variable called radian orientation. Do we have our variable? There it is. So make sure you create a variable called radian orientation, little r, capital O. So the first thing we want to do is set the radian orientation. So what are we going to set the radian orientation to? And this brings us to the fifth phrase that pays, the last one I think I'll do in this video. And then why are we setting the radian orientation? We want to normalize vector. Remember I told you the values of the unit circle, which is just going to be no greater than an x of 1 or a y of 1, no less than an x of -1 or a y of -1. In order to do that, we need to create that normalized vector, we need radians, not degrees. So this is going to create our radians, and not only are we going to do that, but then we're also going to set our vector of x and vector of y at the same time. For this, we need a little recipe here, and I actually created all of my movement over on this tutorial here just to get it to work before I did my code refactoring, and sometimes you might want to do that. So what we're going to do is we are going to set the radian orientation. We need a multiplier, a divider, pi, and some variables. So we're going to go to operators. Actually, we have our variables right here, so let's just grab pi while I'm at it. And we already have the radian orient. We need a trig degree result also. So we need those two variables. And then, like I said, we need some math. And so we need a multiplier and a divider. Okay, look at that. And we're going to just drag that in there. So we're going to say if we get our degrees, our trigonometry degrees, let's just move this over here. We're going to multiply it by 180 divided by pi. Okay, and like I said, we're going to set our direct vector x, which is the directional vector of x. This is the normalized vector, and this is also variables, and it's a set, and so I'm just going to get one. Dirvect x, dirvect y, they are alphabetized. Duplicate. Okay, so one is cosine, one is sine. And so cosine of x, cosine of y. So we go to our sine of, not of x, not of y. You get the idea. Okay. Uh, so we want cosine of trig degree results. Oh, and this is a lot of fun. I'm going to just duplicate that little dude there. And let's see if I can get that variable. Oh, gosh. Okay, be careful when working with variables. I'm just going to drag them and drop them out. Trig degree result. I'm going to, whoa, if I tried to double, okay. Control Z, Control Z, Control Z. All right, we'll just drag them out. Okay, so there's our set radian orientation. Okay, so the first thing I want to do is set that. Set radian orientation. So that's the first thing we're going to do when we start doing our keyboard control. The next thing we're going to do, our up and right arrows, and these are very similar, so we're going to build one out and do the next. So that's an if and sensing, and so we'll go ahead and do that. Actually, I'm going to pull it over here. Sensing, so we're doing a left and a right. No, up and down. Are we doing left or right? We're going to do up and down. And then if so, we're going to do an accelerate function, which I don't think we've defined yet. And this one requires an input, so I'm going to go ahead and define that for you and show you how we do it with an input. It is the accelerate function, so let's make that now. So we're going to make a block, accelerate, and we're going to add an input, and we'll call it magnitude. Because as you remember, we're going to go in a vector. So we're going to accelerate in a vector which has both direction and magnitude. So we're going to want the magnitude when we do it. Okay, so to accelerate in a particular magnitude, how do we do that? Well, we need, I believe, our velocity of x and our velocity of y. So we need to get our variable. We're going to change our velocity of x by the directional velocity times the magnitude, I believe is how we do that. So in order to do that, we need a multiplier. So we're going to take the directional vector of x and multiply it by its magnitude. And you see how like different things sort of light up? Watch where the little lit up circle goes to determine where to drop it. Now, how do we multiply it by magnitude? You just drag magnitude out here. And then we're just going to duplicate this, but change this to velocity of y. Then we're going to have to pull this one out. And actually, we're going to have to multiply it by a negative, which I discovered through experimentation. So we're going to just take a minus sign. Order of operations will I think, do I want to do magnitude first by negative directional vector of y? I believe that's right. Let me look at the one I did over here. Yeah, I did magnitude first and then the directional vector second. It doesn't, I don't think it really matters, especially here, order of operations, right? Multiplication happens before division or subtraction. And I think this would be like parentheses, the fact that this is all inside of one. So this could have been in the opposite order. You just need to make sure you do that minus directional vector x. Okay, so then we're going to accelerate in a forward direction. So we are going to accelerate. So I go to my blocks, I grab accelerate, and then we're going to accelerate in a forward direction. Oh, I need variables for that. Acceleration forward. And I'm going to drag that in, and I'm going to clean everything up. And then I'm going to duplicate this. And now if it's a down arrow, then we're going to do acceleration backward. Okay, and let's clean up our blocks. There we go. All right, so now if we go up, we accelerate. If we go back, we decelerate. We go in the opposite direction. Now we haven't changed any x or y. What we need to do is deal with turning. So let's go ahead and I'll show you how we do that. So I added the point and direction. If we're going to the right, we're going to move to the right. So we're going to need to get our direction. Direction plus rotation amount, and the other is direction minus rotation amount, which is one of our rotation speed. And the other will be minus, so we're just going to go ahead and drag that, drop that in. I'm going to click on that, duplicate it. Let's move one above. Notice how they're each a series of ifs, one after the other. So we're going to go from, instead of right arrow, we're going to do left arrow. And then instead of addition, we're going to do subtraction. And we're going to clean up our blocks. So we need to get the convert scratch to trig degree. And this is here. And we just need our direction whenever we do that. In order to do that, I'm going to pull this out. I'm going to clean up blocks. And I'm going to duplicate. And I'm going to duplicate. And then I'm going to bring that back in there. So this is what it looks like. So we pointed a direction. We're either going plus rotation speed if we're going to the right, or minus rotation speed if we're going to the left. And after each of these, inside of the if, make sure they're both inside of the if, we convert scratch to trig degree. Scratch to trig degree, we already did that. Okay, so we've got our left, right. We've got some functions that are changing velocity of x, velocity of y, changing our direction. Now we just need to start applying this stuff and setting some limits on what we can do. For this, the first thing we're going to do is define a function called constrained velocity. So you're going to need to add that. Constrained velocity does not need any inputs. And we're just going to check there's the maximum velocity. So if velocity of x is ever greater than its maximum velocity, we're just going to set x, velocity of x, to that maximum. So we can never go beyond the maximum. Now we can have less than it. It's only when it's greater than. But if we're going backwards, we have to deal with a negative velocity of x. So if velocity of x is less than, notice, very important here that you get the less than. In fact, let's zoom in on that. So notice the second one here. This is the one we're talking about. Let's stop this so we get that right there. Velocity of x is less than, and we have to put the little minus, and this is the same as saying 0, you know, there. It means the same thing, but you don't have to actually add the 0. And I spend so much time dragging and dropping these things, and I kind of do it. I actually created those, duplicated them, and then swapped out the variables. We do the same thing. If velocity of y is ever greater than the maximum velocity, we set it to the max. If it's less than negative max velocity, we set it to negative max velocity. That is constrained velocity. It doesn't require any inputs. Then we're going to apply some friction. So that set velocity of x down at the bottom. And we're going to set the velocity of y to itself times friction. We need our friction here somewhere. And this is just so that once we're done applying our thrust, we start reducing that amount so that it slows down. Yes, fun physics, not actual physics in space where there would not be friction. Operators. So we're just going to use the multiplication. And these keep getting smaller because, oops, you know what? Whatever. Okay, click that, duplicate. It's easier to duplicate a block than it is a variable. I think we got it, but let's just test it out. Now you see how I reduced the number of asteroids? Okay, well I'm not going in the right, I'm going the right direction there. And I'm not going the right direction there. So something's off. Yeah. So let me just double check to see what I did wrong, and then I'll give you the fix, and then I think we'll be done. I saw my error. Okay, it's under set radian orientation. I forgot to change that to sine, wherever sine may be. Get back here. Oh, let's see if that works. There we go. Look at that. Bam! One of the things you'll notice too, that one other thing I should point out is, let's say I'm going really fast and I collide. Apparently I collided with something. Notice I'm not moving when I start up. There's one last little thing I want to make sure we cover on here, and that is that when I receive ship hit asteroid, you're going to want to change velocity of x and velocity of y back to 0. So this will happen under when I receive ship hit asteroid, velocity of x to 0, velocity of y to 0. Okay, and that's it. And so if you want to see how these things are working, feel free to turn on any variables and see how they work. So the one I think it's worth looking at is the radian orientation, the directional vector x, directional vector y, and its ship direction, and then that trig degree result. So let's full screen this dude one more time. And so notice ship direction is 90, trigger degree result is 0, and directional vector x is 1, directional vector y is 0. And you'll notice as I start going down and I'm pointing down, directional y is 1. Oh, interesting. Looks like looks like I still have some things I need to sort of clean up. But you can kind of see how these values now are changing. Okay, so when you are done, if this is all working, you can go ahead and hide the variables you don't need to show. Keep score and ships there. And the ship direction is under motion, ship direction, and just uncheck it in there. And save your changes if it hasn't saved it automatically for you. And on the next tutorial, we will cover hyperspace and any other weird little glitches that we see going on, maybe even like a start screen and a game over screen in our last tutorial. And so we come to the end of our tutorial on vectors and fun physics. So I hope you enjoyed this video tutorial. Stay tuned for more. We are almost done. I just got to cover tie up a few loose ends of our video. I hope you enjoyed this one. Stay tuned for more. Thank you so much for watching, and I hope you have a good time making your own video games. Talk to you later.